Translate each graph as specified below. The graph of f of x is shown. Translate it to get f of x minus 2. The minus 2 is on the outside, which tells us we are going to be moving down 2 units. So I'm going to take my graph and move it from 1, 3 to 1, 1. And so all of the points have shifted down 2 units. In B, we're going to translate it to get g of x plus 5. So that's going to move it to the left 5 units, because when we add to the inside, it's going to move it left. Let's try another. The first one is f of x plus 3, so that's going to go up 3. So if I have the point negative 2, 0, I'm going to go up 3 units. And g of x minus 4, subtracting on the inside, is going to go to the right 4 units. I'll check that and try another. So this first one says f of x minus 5, so that's going to go down 5. And the second one, g of x minus 3, since we're subtracting on the inside, it's going to go right 3. Give that a check. And then we'll move on to question 2. Below is a graph of x cubed, and we want to do x plus 2 cubed plus 1. Now, there's a plus 2 before we cube, so that's an inside change. So that's going to move it to the left 2 units. And the plus 1 is going to move it up, since it's on the outside of the cube. So really be thinking about inside and outside functions. So let's check that and try another. Absolute value of x minus 4 plus 2. So there's an inside change of minus 4. So that's going to go to the right 4. And a plus 2 is going to go up 2, since that's on the outside. So inside and outside changes is what we're thinking about. Let's check that. Let's continue. The graph is shown, and draw the graph of negative f of x. So that's going to be a reflection across the x-axis. So we're going to go, this point's going to go here, this point's going to stay, and this point's going to go up there. So if we reflect it, it'll look something like this. And from here, it'll go up to 1, 2, 3, up to here. So start here and go up to there. And that's going to be reflected across the x-axis. This one's going to be reflected across the y-axis because it's a negative on the inside of the function. So if we take this point right here, it's going to flip over this axis, so it's going to be over here. And this one is going to switch and it's going to be over here. So from here to here. The graph of f of y equals f of x is shown, graph 1/2 f of x. So this is on the outside, so it's going to be a vertical shrink. So the y value is going to be cut in half. This first y value is 4. So if you cut it in half, 1/2 times 4 is 2. And this y value is 2. So if we cut that in half, 1/2 times 2 is 1. Since it's a line, we should just be able to go from here to here, and all those will work out. Well, this one is very different. Do you see that the 1/2 is on the inside? So that means it's actually going to be a horizontal stretch by 2. These are the ones that work backwards. 0 is still going to be at 0, but if this has an x value of 2, if we double that, 2 times 2 is 4. And this one has an x value of 4, so when we double that, it's going to be 8. When we look at this, it's going to be a horizontal stretch. Oh, notice that you got to click the segment tool 2 times if you want to make 2 of them. So let's check those. And again, here was our vertical shrink by 1/2, and this is a horizontal stretch by 2. The graph of h of x is shown. Oh, sorry, up here. Maybe we'll divide this into 2 parts.